Good morning, student. In previous lecture, we were discuss about the fundamental of electronics measurement. Okay. In that, we were discuss about the different type of the meters, different type of characteristics, etc. Okay. In fundamental of electronic measurement, we were discuss about the characteristics of the measurement. These are the static and dynamic characteristics, error in measurement, type of error, standards of measurement, and the calibration. Okay, the need of the calibration. These are the different topics we discussed earlier. In today's lecture, we will discuss about the analog and digital meter. This is nothing but your second chapter. Today we will start the new chapter. Second chapter is analog and digital meter. Okay, this is your second chapter. In this chapter we will discuss the indicating and display devices, DRSO movement, then PMMC instrument, moving iron, LCD, LED, etc. And also we will discuss about the analog and digital meters. Okay, the type of the analog and digital meters: voltmeter, ammeter, ohm meter, extension of measuring range of the meter, application of meters, and calibration of the meter. These are the different topics. Then first of all, we have to discuss about the indicating and display devices. Indicating and display devices. Okay, the measuring instrument indicate the quantity under measurement. What we use the measurement for measuring any given quantity or any quantity. The measuring instrument is used for measurement. Okay, the measuring instrument indicate the quantity under measurement, which quantity is to be used, which quantity is under the measurement. The measuring instrument indicate that quantity by some arrangements. Okay, there are some arrangement. It may be a dial pointer arrangement. Okay, what dial pointer arrangement or light emitting diode. What are the arrangement? First is nothing but the dial pointer arrangement. Means in such type of instrument where we use pointer to indicating the readings or measurement, that is nothing but the dial pointer arrangement. And second is nothing but the LED or display or liquid crystal display or LCD. These are the different type of arrangement. Means what, in some measuring instrument there are the dial pointer arrangement, and in some instrument there is a LED display or LCD display. These are the different kind of displays. Like in your multimeter, you get reading in the form of the display form. There is a display indicating the reading. In your other analog meters, you get the pointer arrangement, you get the reading by pointing by the pointer. Okay, these are the different type of the indicating and display devices. Okay, then what is the need or essential of the indicating instrument? What? Second is nothing but the essentials of indicating instrument. Then what is the essential condition for any indicating instrument? There are three essential systems for indicating instrument. There are three essential systems. First is deflecting system. First is deflecting system. Second is nothing but the controlling system, and third is nothing but the damping system. These are the three different essentials of the indicating instrument. What? First is a deflating system, second is the controlling system, and third is nothing but the damping system. Okay, these are the different system, and this system produces the following torque. This system produces following torque. Deflecting system produces a deflecting torque indicated by TD. Controlling system produces a controlling torque indicated by TC, and the damping system produces the damping torque. These are the different type of the torque produced by these systems, and this is indicated by TDM. Okay, then we have to know what is the deflecting torque, what is the controlling torque, and what is the damping torque. These are the very important and very simple concept. Okay, first of all, if you have to measure any quantity under measurement by using pointer or in the analog meters. Okay, in analog we use the pointer. Means what is this type of the reading is given on your meter. Okay, this is nothing but the scale on your analog meter. 0, 1, 2, 3, 4, 5, 6, 7, and this is your pointer. Okay, when there is a quantity under measurement and you have to measure that quantity, that time your pointer firstly is on the 0, and after when you are adding weight or anything you have to measure, that time your pointer move toward a reading. Means what? The quantity under measurement, it gives the reading of the quantity under the measurement. To move that pointer, which torque is generated? That is nothing but the deflecting torque. Means what? If you are adding you are adding the weight of 2 kg and you have to get the reading of 2, that time your pointer is moved from here to here on that point, 2 point. Okay, to move your pointer from 0 to 2 for getting that reading, you are moving your pointer from 0 to 2. That is nothing but the deflecting torque or the deflecting system. Okay, but after that you have to control your pointer on that point or the quantity under measurement. For that you need a controlling torque to control your pointer on the quantity, what is your reading or quantity under the measurement. That is nothing but your controlling torque. Okay, but when you remove a weight from the given quantity or you are removing the weight, that time you have to move your pointer from this side to this side. Okay, means your pointer may be flexible for giving the different kind of reading or move both the direction or left side or the right side. Okay, that's why you need a third torque is nothing but the damping torque. These are the different type of torque which are essential for the indicating instrument. Okay, first of all you have to know that there are the 3 systems for indicating instrument. First system is nothing but the deflecting system, second system is the controlling system, and third system is the damping system. And this system produces the different type of torque. First torque is deflecting torque, means to move the pointer from 0 to quantity under measurement reading. To giving that reading we need a deflecting torque, and to control that pointer at that point means you don't have to move that pointer, you get the increasing value or the less value. That's why you need a controlling torque to control that pointer or control the given reading. After that, to move your pointer right side or left side, means it will move here also. After removing the weight or removing the quantity, your pointer again came here at the previous stage. For that you need the damping system. Okay, these are the different system and different torque in your instrument indicating instruments. This is nothing but the scale and this is your pointer. Then you have to know what is the definition of the deflecting torque. To produce the deflection proportional to the quantity under measurement. What? To produce the deflection. Deflection means what? To produce the deflection from 0 to 2 or 0 to 3, 4, any quantity, that is quantity under measurement. To produce that deflection proportional to the quantity under measurement, the moving system of measuring instrument experiences a movement. The movement is transferred to pointer which deflect on the scale. That is nothing but the deflecting torque. Okay, after that, the deflecting torque, there is a controlling torque. The controlling torque is nothing but the deflecting torque causes the pointer to deflect from 0 position, and it may attain any position on the scale. Like I said earlier, when the deflecting torque is causes, your pointer is deflect from that 0 position and it may attain any position on the scale. That is depend on your reading or quantity under the measurement. Okay, but it is desired that the deflection should be proportional to the quantity which is to be measured. Means what? The deflection should be proportional to your quantity under measurement, is not be exceeded by some value or not is less than that value. That's why to controlling torque or the quantity to be measured, so controlling torque is essential for control that pointer or control that or the process. Okay, after that your third torque is nothing but the damping torque. Okay, and the damping torque is necessary for the better response of the instrument. For the better response means deflection torque should be right and the controlling torque should perform good. That's why the damping torque is required. Damping torque is necessary for the better response of your instrument. That is all about the deflecting torque, controlling torque and the damping torque. Then firstly we will discuss about the deflecting torque in detail. Okay, the first torque is nothing but the deflecting torque, that is TD. Okay, the different effect uses to produce the deflecting torque. The deflecting torque in electrical measuring instrument is produced by the mean of different effect of electric current. For example, the magnetic effect, the electrostatic effect and the heating effect, electromagnetic induction effect, chemical effect, Hall effect. These are the different type of effect. Then what? The deflecting torque in electrical measuring instrument is produced by means of different effect. And this is the deflecting torque effect. Then effect of current and their use in the measuring instrument. There is a one table is given in your syllabus, that is the what are the effect and what are the measuring instrument. Then for magnetic effect we use ammeter. For electrostatic effect there is a voltmeter for high voltage measurement. Then heating effect, for heating effect the measuring instrument is also the ammeter, voltmeter and the wattmeter. After that the induction effect. For induction effect we use the watt hour meter, that is the energy meter or wattmeter. Okay, for the Hall effect we use the flux meter and the ammeter. These are the different type of effect and different type of measuring instrument for that effect. Then what is the requirement of the moving system? In your measuring instrument we need the moving system. Then what is the requirement of that moving system? A requirement of moving system. The moving system should produce desired deflection with minimum power consumption. For deflection we need the moving instrument, that is the first point. It should be high in weight. The frictional losses should be minimum in at the time of the deflection. Your position or your operation may be frictionless or frictional losses should be minimum, we can say. Okay, there are different ways of moving system. First is nothing but the suspension. To understand that concept there is a simple diagram. Okay, that is nothing but the fine ribbon, and that is your coil. The coil of the instrument is suspended using a fine ribbon made up of the phosphorus bronze. Here the coil of the instrument is suspended using a fine ribbon, that is the fine ribbon which is made up of the phosphor bronze. Okay, the system is used for highly sensitive instrument. It can be used in vertical position only since the coil is suspended vertically by means of the fine ribbon. That is the different way of moving, or the different way of the suspension. You know about the suspension in your bike, we use that concept. Okay, when to move your instrument or the system is used which is highly sensitive, where we use that suspension. It can be used in vertical position. It is used in vertical position only since the coil is suspended vertical by means of the fine ribbon. Your coil is suspended in the vertical. That's why we are connecting the fine ribbon vertically here. After that, your second is taut suspension. Taut suspension. In taut suspension we use coil at the place of the fine ribbon. We use coil here. Okay, again coil, and again here we use spring. This is your spring, this is coil, and this is nothing but the ribbon. That is the taut suspension. Okay, the taut suspension. In taut suspension, use a spring to adjust the tension on the ribbon. Here we use fine ribbon to adjust the tension, to adjust the suspension, and in taut suspension we use the spring. That is the only difference between the suspension and the taut suspension. We are using spring here for to support the top and the bottom of the coil. To support the top and bottom of the coil, we use the spring here. After that, third is nothing but the pivot and jewel bearing. Pivot and jewel bearing. These are the different ways of moving system. Okay, these are the 3 different ways of the moving system. In pivot and jewel bearing, we use the pivot and the spindle. This kind of structure is called as the pivot. Okay, in the form of that. This is your pivot, this is the coil. Same structure behind that. Sorry, this is triangular. Okay, this is your pivot, support, jewel, spindle, and this is your coil. This is the structure of the pivot and jewel bearing. The spindle, that is the spindle, that spindle carries the coil, and spindle is support at the both end of the pivot and the jewel bearing. This spindle is supported at the both end of the coil, and this will support your coil. Okay, the contact area between pivot and jewel, that contact area, the contact area, these both are the contact area. These contact areas between pivot and jewel bearing is kept small to reduce the frictionless losses. What the contact area between that pivot, this is your pivot and this is your jewel bearing, should be less. Okay, reduced to the contact area between pivot and jewel bearing is kept small to reduce the frictional losses. Okay, the deflecting torque produces a turning moment of the spindle, due to which the angular deflection takes place. Here is the angular deflection, because the deflecting torque produces a turning moment of the spindle. That's why we are using here a angular deflection. Here is the angular deflection takes place.